less than 3.7. I think in comparison to 3.5 and 3.6, you'll definitely like a little bit more. Also goes along with a little bit of other stuff we've done. Okay. So as we talk about 3.7, we're talking about transformations, which when we get to the back side, which that will probably be more like Monday, transformations. You know that chart we've been using since almost day one in this class, where we talk about left, right, up, down, stretches, shrinks, all of that. We're still going to be talking about that, okay? But before we get there, we're going to talk about something called even and odd functions, okay? And this is one of those things that is at the bottom of your pink paper there, okay? Even and odd functions. With even and odd functions, there's two ways you can think about this, okay? With even functions, one, the easiest thing is to look at the fact that it is symmetric about the y-axis, meaning there's vertical symmetry, right? And it's specifically focused on the y-axis. So this is your even function, okay? The other way to look at this, and this is when you only have an equation, is that f of x equals f of negative x. That's your other option, okay? So if a function is even, it has this symmetric about the y-axis, or, and we'll talk about this here at the bottom here, f of x equals f of negative x. If a function is what we call odd, okay, it is symmetric about the origin. We can talk about symmetric about the origin a couple of different ways. You'll notice here you see, I don't know how to describe that, but to me, you can also think of it as a rotation. Okay, so you can think about with symmetric about the origin, it's basically a rotation of 180 degrees. I also talk about it being two reflections, so like reflecting across both axes. So reflect across the x, reflect across the y. Or f of negative x equals negative f of x. That's the other piece there. Okay? And then our third option is just when it doesn't fit into the even or the odd, it's just neither. Okay? So even, we see the symmetry across the y. Odd, we see a symmetry through the origin. Neither means there's not symmetry there. Okay? Or at least it's not centered someplace. Maybe it's symmetric, but it's not centered on the x-axis, y-axis, at the origin or anything like that. So in that case, these do not hold true. The f of x equals f of negative x or equals negative f of x. And there's the symmetry isn't there. Okay? Oh, with the curves? Okay. The easiest way to look at even and odd is if you have a graph. Okay? If you have a graph, that's going to be your easiest way. As we look at A, it's classified the polynomials as even or odd based on their graphs. So as we look at this graph, does it look even? It has symmetric across the y-axis. Does it look odd? It has symmetric about the origin, or neither of those categories. Why?
Because it looks like the odd example.
Because it looks like the odd example. Fair enough? Are you guys with her on that one?
Yeah.
Okay, and here's the deal. It's definitely not even. I can't fold the y-axis in half and get one half landing on the other half, right?
Yep.
So it's definitely not even. And so, can I rotate this 180 and it'd be the same? Yeah, if I rotate upside down, it's going to be the same. Or if I take, I always kind of think of it as quadrants. If I take this quadrant 1 and I reflect it across one axis, like reflect it across the x-axis, now it's upside down, reflect it across the y, it lands in quadrant 3 on top of that. So this is indeed odd, specifically symmetric across the origin. Okay? What about B?
Even.
Even.
Because whenever you fold it, it lines up.
Okay.
Across the line.
Can you fold it across the y-axis?
Mm-hmm.
Okay. So we definitely see the y-axis symmetry. So this one is even. And symmetric across the y-axis. Okay. C.
Yeah, I just, because if you rotate it, there's 80-inch line, right? No,
Agree or disagree?
I agree.
If you fold it down enough for hospital, it's symmetrical.
Okay.
Plus it does one whole top key, like the heat.
The key is, if we're talking odd, symmetric about the origin, does this function in general have that idea where we can rotate it?
Yes.
Yes. Now, is it specifically rotating about the origin?
No.
What's the difference with this problem?
It's origins of 1, not 0.
Yeah. If this particular graph was centered at 0, 0, I'd be all for it, that it is symmetric across the origin. Is it centered at 0, 0?
No.
No. So if I take this graph and I rotate it upside down, well, now this central point that's 1 above, it's now going to end up being 1 below. So this one does fall into neither. Okay. We never had a question about even. We knew it wasn't symmetric across the y-axis. The fact that it is not centered at the origin is what ends up making it not symmetric across the origin. Okay. If I fold, for instance, if I start folding this top piece down, it's now going to be at 1 below instead of 1 below. It's not going to end up being the same. Okay. D.
Odd. Because it goes through the origin.
Okay.
Yeah.
Is D centered at the origin?
Yes.
Yeah, this one is. So this one is odd. Symmetric about the origin. Okay. What about E?
Neither. Even. Even.
No. Even. Even.
Yeah. Even.
Are we sure?
Yes,
Yes.
very sure.
Even is what? Symmetric about the
Why?
y-axis. Can I fold the y-axis in half?
Yes.
And it lands on top of itself. It's upside down, but that's okay, isn't it? So this is indeed even. And that's because it's symmetric about the y-axis. Okay. Let's look at the bottom piece. Okay. I'll be honest. Okay. And as you move forward in math, there are reasons that we use the even and odd information. Okay. There are ways that it can be helpful. Right now, this level is just learning the difference between even and odd. The easiest way to tell if a graph is even and odd is if you can look at a picture. Look at the graph. Now, are we always going to be provided a graph? No, of course not. So the bottom of the page talks about, okay, if we're given a function, is it even, odd, or neither? Okay. Now, I guess I'm going to kind of have to flip back and forth. This part means instead of looking at the graph, we're looking at these pieces right here. Does your function f of x equal what you get when you plug in negative x or what you get when you multiply by negative x? Okay, so if you're given an equation, not a graph, and you're asked to find whether it's even or odd, my suggestion is always start by finding f of negative x. Okay? What it means to find f of negative x every place I see an x, I'm going to replace it with negative x. So in this case, it's 4 x to the fourth. So instead of x to the fourth, I'm going to say negative x to the fourth plus 5. Okay, notice I put that negative x in parentheses. And here's the deal. We want to see, when we clean this up and multiply it out, is it the same as the original, or is it different? So, as we clean this up, what do you know about negative x raised to the fourth?
It will be
A negative raised to an even power makes it a
positive.
positive, yes? Okay, so negative x raised to the positive fourth is going to be positive x to the fourth. So 4 times positive x to the fourth plus 5. What do we know?
Back with nothing.
Okay. Did we end up back at the same?
Wait,
Yeah, we did, didn't we? We ended up where we had f of x, and we got f of negative x, and they are the same. If you look up at the top, what does that say? If those two are the same, if f of x equals f of negative x, then my function is even. In other words, if I were to graph this, it would be symmetric across the y-axis. Okay, this doesn't work on a test, but could you plug something like this into Desmos on homework if you want verification? Yeah. Okay, we still need the process, right? We still need the process, but your verification is 4x to the fourth. It'd be a quartic, so it'd be a kind of like a fat or parabola moved up 5. Okay. So that's an example of even. Okay, B. Again, my suggestion every time, start by putting negative x in. So I'm going to start by finding g of negative x. So 2 times negative x to the third plus 3 times negative x. Well, what do you know about negative x raised to the third? What do you know about negative raised to a third?
It's a negative.
It's going to be a negative, yes? So now if we have negative x to the third times 2, what's that going to make this term? Negative 2x to the third. Okay? Because I took that x and raised it to a negative, or to an odd. Negative x to the third is negative times the 2 makes it negative 2x to the third. What is 3 times negative x?
Negative 3.
Minus 3x. Okay. What do I know right now?
It is not even.
Okay. Does g of x equal g of negative x?
No.
No. And I don't know, do I have room to squeeze that comment in there? Since g of x does not equal g of negative x, I know that this is not even. Now, am I done with the problem?
No.
No, because now we've got to test and see if it's odd. Okay. I just know, and it's not that you have to write down not even, but that's just kind of like what my brain's thinking is, okay, it's not even. Now I've got to check odd. So to check odd, I've got to look at negative g of x. Now this one's different. Negative g of x has a negative out front. So negative g of x says we take the whole equation and we multiply by a negative. So I'm going to write it as, now, what equation? We're taking the original equation, right? So I'm going to take negative and I'm going to multiply the whole equation, 2x cubed plus 3x, by a negative. So in other words, think in terms of distributing a negative, okay? If we distribute a negative, what does this end up looking like? Like right on that line. If you distribute that negative, what does this become? Okay. Negative times 2x to the third is negative 2x to the third. Negative times 3x is minus 3x. What am I supposed to be comparing negative g of x to? Yeah, if you go back up here, in order to be odd, we have to look at, and this is stated, f of negative x equals negative f of x. So does the original matter? The original doesn't matter. I want to know about g of negative x and negative g of x. So what do we know about those two? Are they the same? Yes. So if g of negative x equals negative g of x, what do we know? This is an odd function. Okay. You'll start to notice some trends as you go through these. Okay, shall we try C? What am I starting off finding? F of negative x. I'm writing mine in 2 steps. If you're getting confident enough to where you could just write the answer, more power to you. So f of negative x. Every place I see x, I'm replacing with negative x. So 7 times negative x raised to the 5th minus 2 times negative x raised to the 2nd plus 4. Okay, well, what do you know about negative x raised to the 5th? A negative raised to an odd is going to be negative, so this is going to become negative 7x to the 5th. What do you know about a negative x raised to a 2nd? That's going to be positive. We already have a negative here, though, so it's going to stay minus 2x squared plus 4. Okay. What can your brain tell me right now? Okay. Right now, I know that f of x does not equal f of negative x because there's one signs difference, isn't there? The other 2 pieces stayed the same, but there's one signs difference, so this is not even. So now we're going to check for oddness. So we're going to find negative f of x. So that means I'm going to say the negative of, I'm putting in parentheses, 7x to the 5th minus 2x squared plus 4. Negative f of x says I'm going to multiply every term by a negative. So what do we have? Negative 7x to the 5th plus 2x squared minus 4. What do you know here?
It is not the same. Wait, no, it is. It is neither.
These negatives match, but we've got plus 2x squared and minus 2x squared, minus 4 and plus 4. Does f of negative x equal negative f of x? No, so that means this is not odd. If it's not even and not odd, then that means
Neither.
it's neither. I don't know. Had some of you guessed it was going to be neither because I've done an even, I've done an odd, so what's the next option? It's got to be neither.
The last one.
What's that mean about D?
Even.
Because could be any of them,
It could be any of them.
but
You
it
can
won't be
stop
neither.
Is this an emergency?
But it could start back over.
I think it's gonna be all of them.
Okay. So this is your wild card one, right? We've done the other three. What is it? So regardless, I'm always checking f of negative x. What do you know? Negative x raised to the sixth minus 2. What do you know about negative x raised to the sixth?
It's positive.
Positive x to the sixth minus 2. But was he right for the right reasons?
No, because I meant to say even, or I meant to say positive.
Okay, right here. Did these end up the same? They do. Since f of x equals f of negative x, this is even. Okay,
Start this Monday so we can have a refresher and then we all work on 3.6 homework.
you read my mind,
Hey,
really.
you wanna go over number 3 on homework?
Yes. Okay, we're going to pause here. We'll pick notes back up on Monday. Okay, I will probably put the 3.7 homework out there at some point. I just haven't yet. But we're going to use this 12 minutes and look at homework.
Hey, every minute counts.